as Ross Perot has said, and I'm going to repeat a couple times tonight as I show you the details, the devil is in the details. Because it's the details that allow you to discriminate between various ideas, various models. So what are we left with? We are left with a physics that apparently is successfully able to predict planetary activity, the locations of phenomenon on the surface of these spinning worlds, ranging all the way from the placement of sunspots and solar activity on the sun, all the way out to the last planet currently in the solar system, the planet Neptune. Now that is a pretty amazing track record for a theory derived from a set of objects on a planet that should not exist. Because remember, this all came from our decoding of possible artifacts on the surface of the planet Mars. Now the neat part about this is that it's all checkable. It's all testable. It's all verifiable. All one has to do is be willing to cast your prejudices aside, to stand back in a little humility and a little awe and simply begin to do the homework. For 18 years, since NASA took the photographs of the monuments of Mars, NASA has not publicly done any of the homework. That has fallen to a small but growing team of outside researchers who have tried to pursue good science while both metaphorically and in some cases otherwise being shot at. Which brings us to the moon. The Earth-Moon system is unique. My late friend Isaac Asimov has called this a double planet system. The reason is that the Earth, roughly 8,000 miles across, is orbited once a month by an object that is roughly 2,000 miles across, roughly 1/4 of its size. Remember, the ratio of Jupiter and Saturn and the larger planets and their moons is grains of sand orbiting huge beach balls. So the first thing we start out with in looking at the moon is its uniqueness in terms of its size relative to its primary, relative to planet Earth. But things quickly get more interesting. As we begin to look at the moon, one of the first things you have to remember, of course, is that you're only going to see this side. This is the Earth side. There is, by the way, no dark side. I don't know where that ever got started. Every spot on the surface goes dark for 2 weeks because you have 2 weeks of day and 2 weeks of night. This day-night period is the day of the moon and is equivalent to its year, which is the time it takes for it to go around the Earth once, which is roughly 1 Earth month. So there are 13 moon months in an Earth year, etc., etc., etc. So this will give you some feeling for what we're dealing with. Now, from time immemorial, as men and women were looking at the moon and gazing at it with the naked eye and then with telescopes, which brought it closer and closer and closer, one of the things that has struck everyone is that the moon appears to be divided into two main regions, the dark stuff and the light stuff. Galileo thought the dark stuff were seas, oceans. Ergo, the Latin term for these dark areas, mare, meaning seas. But they're not seas, the likes of which we've ever known on Earth. They're waterless, they're airless, and we'll get into the details on that in a few moments. The light things, the light areas, are called highlands, or terra. Terra meaning land in Latin. Well, as you continue to move closer, as you focus in on the very center of the lunar disk, one of the kind of interesting things that you will notice is that the moon has now had visitors, including the Pentagon. This is the Clementine mission, which took over exploration of the moon a few months ago and then also mysteriously vanished. We'll get to that in a little while. But for the first time in 23 years, the only object to go back to the moon that we know of from this country was this little 500-pound satellite put together by the Naval Research Laboratory, instruments built by the Brookhaven National Laboratory, with consultancy by a small group of NASA scientists for the photography. As we continue to move in, looking at the moon, one of the things that you will notice in this central region, which is called Sinus Midi, which means Central Bay, one of the things you'll notice is that there appears to be an 18-mile crater called Oort. And in Oort, in the middle of the moon, if you were standing in Oort at the right moment and looking directly overhead, there would be the Earth. At the closest point on the moon to Earth, there is a crater with an equilateral triangle marking its interior. The symbol we have decoded from the monuments of Mars. It was this symbol which basically focused our attention on this region. Because in the idiom that someone has been in this solar system long before, that someone has left a series of monuments or structures or artifacts designed to tell us something of their presence, of their history, of perchance their discoveries, their knowledge base, their achievements, perhaps to help us to achieve similar achievements. This is an amazing discovery. I mean, we've looked now at an awful lot of craters, and this is the only crater that I have been able to find that has a perfect equilateral triangle in the surface. Now, this is an Earth shot. This is from the Yerkes Observatory. This is what astronomers should have seen and have wondered about in the Gaussian model of intelligence will put geometry on other worlds. And notice this. On the rims of the crater, spaced 120 degrees around from the vertices of the inscribed triangle, there's a bright region, a bright region, a bright region. So what we have are two interlocked tetrahedra. Here and here, if you think of this as a three-dimensional construct, which of course a two-dimensional equilateral triangle can become if you do a dimensional rotation. That was how it began. What we then began to do was to try to acquire photography taken by various space missions around the Oort region on the theory, on the model, that someone at some point in the space program may have photographed something important and significant, artificial, in this region of the moon. It was nothing more and nothing less. Now, it's really unusual and odd and wondrous that the crater we found with this symbol is the crater that, under certain times of the month, is literally right under the sub-Earth point. And you can look directly overhead and see the Earth as a 2-degree spinning sphere. So what we began to do was to look at a series of NASA data. There were 3 missions that I was focusing on. One was data collected by this spacecraft. This is the Lunar Orbiter series. I'll describe the technology of Lunar Orbiter in some detail in a couple of minutes. It photographed the moon from the mid-1966 to late 1967. It actually took film to the moon and scanned the film and then read it back to Earth. Then there was Surveyor. This is Alan Bean standing next to Surveyor. This gives you an example of the scale. Surveyor was our first successful unmanned spacecraft to land on another world. It stood about the height of a man. It contained one very important television camera, which looked out about the height of a man and scanned the horizon and the sky and the ground. It carried a sample arm to dig trenches. It carried retro rockets to land softly, electronic boxes, solar panels, high-gain antenna. It was our first robot explorer from the surface of another world. And on Apollo 12, the second Apollo mission, NASA directed the lunar module to land near Surveyor to bring back pieces for analysis of what would happen to terrestrial materials exposed for 31 months to the lunar environment. And then, of course, there was Apollo itself. Apollo which was a remarkable achievement in the history of mankind. More men and women focused in a brief period of time on a single project of unimaginable scope, successfully achieving it, and all without firing a shot. What I want to do for a moment here is to take you back in time. I want to show you the world on which you live.